This question says a person is standing at the top of a 50-foot building. She throws a ball in the air with an initial speed of 12 feet per second, very soft toss. The height of the ball is modeled by that equation. We want to find the height at 0 seconds, the height at 1 second, and how many seconds must elapse before the ball reaches its maximum height. What is that maximum height? And then how many seconds must elapse before the ball hits the ground? So let's first look at the 0 and 1 second. So we have this function. I've got to plug in 0, I've got to plug in 1 to see what those values are. So I'm going to go ahead and pull up the graphing calculator for that. So for 0 seconds, -16 times 0 squared plus 12 times 0 plus 50. Now you know the answer to this, right? 0 plus 0 plus 50 is just going to be 50, but that doesn't surprise us, right? Because we started on a 50-foot high building and she has a soft toss into the air. So at 1 second, now what is the height? Where is it at 1 second? So -16 times 1 squared plus 12 times 1 plus 50 gives us a height of 46 feet. So it's not even as high as the building. So she had a soft toss. 1 second later, it's actually below her feet. It's 46 feet above the ground. We certainly could have done this another way. We could have done it with our table. So if I go to second table set, starting at 0, 1, automatic, that looks good. Second table, it'll list my values. Once I put a function in there, which I haven't done yet, I'll do that now. -16 x squared plus 12x plus 50. Let's try that again. Again, second table set, you always start there to see where you want to begin. I'll begin at 0, going up by 1, and then second table. At 0 seconds, 50 feet high, 1 second, 46, as we said, 2 seconds, 10 feet high, between 2 and 3 seconds, it hits the ground. We're going to want to find that as well. But I'd like to know what is the maximum value. So one of the questions says, how many seconds must elapse before we reach the maximum height? So let's go ahead and think about that. This is a parabola of the form y equals ax squared plus bx plus c. This is a quadratic function. A is equal to -16. That's negative. If a is negative, the parabola will have this sort of shape, and it will achieve a relative maximum. Or if you'd like an absolute maximum in this case. Now, where is the vertex? The vertex is at the form x equals -b over 2a. So I get -b, -12 over 2 times -16, -12 over -32. What does that reduce to? Well, we get 0.375. As a fraction, that's the same thing as 3/8. So 3/8 of a second after her soft toss is at its maximum height. And then boom, and then it starts falling. But what is the maximum height? I've got to plug 3/8 into the function to find out what that is. So we know 3/8 of a second in, it reaches its maximum height. If I plug 3/8 in, which I'll do the long way here first, -16 times 3/8 squared plus 12 times 3/8 plus 50. And we get 56.75. So the ball achieves a max height of 56.75 feet, 3/8 of a second after it is tossed. Another way I can show that, let me just show you another shortcut way. How do I get that 3/8 plugged into the function? Uh-oh, I guess I messed that up. Let's fix it. I noticed a double negative there. Let's fix that. And I will delete that one and see if that changes. It's going to let me delete it. There we go. I need one of them, not two of them. Now I'm going to hit enter and change it to 52.25. So let's go ahead and fix the page. So it wasn't 56.75, it was 52.25. Once we notice the typo on the calculator. Let's go back to the calculator. I do want to show you another way to get that. I'm going to plug 3/8 into my function. Vars, y vars function, plug in 3/8. And I should get 52.25. So it just goes up a little bit less than 3 feet, 2 1/4 feet, and then it starts falling down the side of the building. So indeed, once we corrected the error on our calculator, we have the ball achieves a max height of 52.25 feet, 3/8 of a second after it is tossed. Now, when does it hit the ground? That was our last question. So you can see this is our equation. We want to know when it hits the ground. And it also might be nice to see if we can check our work on the maximum height. So those are two things we can also get from the graphing calculator. So let's look. I have the y equals in the calculator. I need to create a window if I'm going to look at this. I don't need a whole lot of time. So I'm going to guess -1 to 2 with 0.5 scale. I think worked when I tried this before. Y min of -10 and Y max of 100 with a scale of 10. That might look good. I think my max, my X max might have to go to 3. Let's change it to 3 or 4 maybe. And let's try this window and see if this gives me a decent image. Notice the negative numbers really don't make a whole lot of sense. So what do we have? Negative 16x squared plus 12x plus 50. We can look at our table as we did before, right? And we see between 2 and 3 seconds, it should get to 0. So where's my graph? Okay, graph it again. What do we have? Each one of these tick marks corresponds to a half. So don't let that confuse you. So beyond 2 seconds is where it seems to hit 0. How about the maximum? Where does the maximum occur? We'll move the man in the spaceship up here somewhere. Remember, we thought it was 3/8, 0.375. Is that about where you think it's going to hit its maximum? Well, let's try it. Second calc, maximum. We did our analysis. And we said 3/8 of a second is when it would hit its maximum of 52.25. There's a, move it a little bit more to the left just to make sure. Left bound, right bound, guess. 0.375 basically, and 52.25, so that reinforces it. Now we want to find out where it crosses. And again, when we did our tracing, we noticed it was a little bit more than 2. So before I let the calculator solve that, let me go ahead and solve it by hand, and then we'll check it with the calculator. So I need to find out, when does this parabola have a 0? So somewhere around 2.2 seconds, in that neighborhood. So let's go ahead and do our analysis. So here's our original function. Negative 16x squared plus 12x plus 50. I want it to be equal to 0. Equals negative 16x squared plus 12x plus 50. Remember, this is a quadratic equation. 0 is ax squared plus bx plus c. So a is negative 16, b is 12, c is 50. So I get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You get x equals negative b, negative 12, plus or minus the square root of b squared. So that's 12 squared, minus 4 times a times c, 4 times negative 16 times 50, all over 2a. So 2 times negative 16. So we get x is negative 12, plus or minus the square root of 12 squared is 144. It might be actually helpful to do this on the graphing calculator. Let me jump there. We'll get back to the graph here shortly. 12 squared minus 4ac, 4 times negative 16 times 50. What does that give me? Twelve squared minus 4 times negative 16 times 50 is 3,344. All over 2 times negative 16 is negative 32. So I have two answers here. I have the plus and I have the minus. So let's do them both. So x is negative 12 plus root 3344 over negative 32, and x is negative 12 minus root 3344 over negative 32. Remember, any negative number doesn't make any sense because of how we're defining this. Times 0 is when she tosses the ball. So let's do this upstairs. Negative 12 plus square root of 3344 divided by negative 32 gives me negative 1.432. So that doesn't make any sense. Now we'll try the other one, negative 12 minus, which I can do a shortcut. Second enter what you did before when I made my mistake, and just type over the minus sign. Or excuse me, the plus sign, make it a minus. And I think that's in the right place, make it a minus. And see what I get. 2.182. So we hope that that's when it hits the ground. The 2.182 seconds is when it hits the ground. But I certainly can check that on my graphing calculator. So I'm going to do that now. We have our graph that I showed you before. Could you believe that that's 2.182 seconds where it hits the ground? Second calc 0 finder, which is number 2. A little bit to the left of where it crosses. That looks good. A little bit to the right of where it crosses. That looks good, and a guess. And I get 2.182. So it reinforces what I had. So I believe we have answered all the questions. 2 decimal places, 2.18 seconds.